During our file handling sessions, we have started to we started our journey with understanding what is stream. Then we used uh, raw classes to interact with the disk file. Like we started reading a file using a byte by byte order. Then we learned about what is a drawback of reading a file byte by byte. Then we have seen buffers. Then we also explored about what will happen if encoding scheme of writing while writing the file on the disk, and if we use a different encoding scheme while reading the data from the disk, the data representation might be wrong. So we have seen that also, and in that same session we also explored character-based reading and writing stream. One part that we have to explore today is what about writing a state of something on the disk and to retrieve a state of something from the disk. Now, to be very precise, the state in the sense reading and writing the data which is related. Like, let me share my screen and let's discuss the story. Give me a moment. I will share my screen immediately. Its screen is visible. Can you people see the screen? Okay, great. Great. So I close the chat window. So let's say that you people have some related information. Let me open up a notepad. Let's say you have a person object of something called as a person, and that fellow have a field called as ID and also field called as a name. And let's say there are 10 objects and each object have a precise value of what is ID and what is name for that particular object. Now, if we say ID, let me give it value 1. And if I assign name, I will say, let me give value my own name, Samir. Now, what I want is, I want this information to be saved in the text file, right? And what if, let me save this file and let's call this file as, let's go to my Java. I guess there is my Java, right? And in that, let me create a folder called as file IO. Okay, it is already there. So let me go to the folder file IO and save this file as let's say sample.txt. Fine. Now this file is saved on the disk and the file name is sample.txt. Now what if you write a program to read the data from the file? And the data, of course, the data we can prefer either reading one character at a time or reading one byte at a time. Depending on how you prefer to read the data from the disk, the information will start getting read from the disk. Now let's assume that we people are reading one character at a time from the disk. Now when I start reading the file from the disk, I will read first I, then I'll read this D, then the assignment statement will come, and then the value 1 will come. Now these are four separate read operations, and altogether this information is not related for the file reading program. So what will happen? The program will read this all independent characters one by one, and for the program, this information is not making any sense. Now one would say that okay, what does it make any difference? Because you people will display this information in a serial order. That is, ID will be displayed as 1 and then the name Samir will be displayed. Now let me put one more object in this file. Let's call this object as ID is equal to 2 and name is, let's say, name is equal to Patil. Let me create one more variable. ID is equal to, let's 3, and let's say name is equal to QP. right? So there are some general names. Now, what we want is we want this things to be read as in a group. I want this ID1 to be associated with name Samir. I want this ID2 to be associated with name Patil. I want this ID3 to be associated with name KOP. That is not possible with this text file. For this text file, each and every information is treated as a separate entity. So this all four characters are separate. The name four characters are separate. Assignment is the fifth character. Then the double code is a separate character. The five characters in the name are different, independent of each other. And this double quote, closing double quote, is also independent character. So there is no way that the text file is able to relate this information as in a single entity. Now, one would argue that, okay, doesn't matter because still we are able to get this information from the disk. Now, let's say that we have an operation. Let me go to the chat box. Okay, fine. There is no query. I assume that you people are getting what I'm talking. And with this assumption, let's discuss the next concept. Concept is, let's say that, okay, you are fine with writing this information on the disk. Your life is simple, working fine. Program is, you are able to add the information in the file, go on, so on. The file has become lengthy. Let's say that you have 100 objects in the file. After this, after having 100 objects in the file, one day you want this information to be updated. For example, you got a query that, okay, ID number three, which is in the third place of the file, that name is used as in a short name, which is KOP. Now you have received a request that you have to like update this KOP to the full name from the short form, update it to the KOP is the earlier value. Now somebody has requested to update it, or the person who owns this ID3 have requested you to update the value to Kolhapur. Kolhapur, right? Now, when you have updated this value to Kolhapur, you have to go to the ID3, locate name, then double quote KOP must be replaced. Now, see, this is the complexity. You have to replace this KOP with Kolhapur. So this should happen like this line has to be deleted. Like from the text file, this has to be deleted. And more precisely, this KOP has to be deleted and it has to be replaced with Kolhapur. Now, if you are dealing with the text file, this is a tedious job. What are the tedious job? First of all, this entire information is independent of each other. You have to find a value which is 3 in the file. When you find value 3 in the file, then you have to read this 4 characters, then the assignment, then you have to find this double quote. Then whatever comes in between this opening double quote and closing double quote has to be replaced with Kolhapur. And again, you have to put a double quote and all. So this file handling job is a tedious one. Now, not only this one, like not only the file handling job is tedious. What if you simply want to delete this ID number 3, ID number 2? Like say that this ID number 2 value is no longer required and you want to delete this value from the disk. Now what you have to do is deleting this ID2 means this complete space has to be deleted and ID3 must be shifted in the text file. Now who is going to do this? Of course, this thing is not going to happen automatically. The programmer has to take care of this thing, like deleting the ID assignment to the name NAME assignment single double quote PATIL double quote, and then delete this entire space which was allocated in the text file to this ID2 and its value, and then shift this ID3 and name to the second place. Okay, so deleting becomes issue, and editing the information of the existing object is also an issue. Now, let's assume there is one more thing that we want to do. Let's say that ID2 has been deleted. Somehow ID2 has been deleted for some work. And now the new request has come that we have to insert ID number 2 at the second place, right? Then what you have to do is by handling text file, you have to create a space between ID1 and ID3 values, and this space has to be created, and here you have to insert this all together new information, which is ID assignment 2 and NAME assignment, and let's say this new value is MH or MH for representing Maharashtra state, right? So it has to be done. Now To summarize this, I can use one word that is called as manipulation of a text file is a tedious job. Manipulation of a text file is a tedious job. And manipulation means adding a new information. See, if we want to add a new information, you have to travel the entire file and go to the end of the file and then create a space and then add a new value. So this manipulation is still a tedious job in the case of a text file. And there is no way to represent this information as a single entity. Again, this information is represented as a different entities. So these all issues have forced people to think about what is the solution, right? And the people have come up with the solutions called as databases and writing a state of object to the disk. Now database, we will start with the database, and in that again we have to revisit the concept of why the disk manipulation is a tedious job and how database makes our life simple. So we will see that concept, we will revisit this concept in the while learning the databases. Right now, the first thing that we have to resolve is, so here pick up a point. Now mark this point in your head, like these are the issues. Like first of all, this ID assignment 1 is not related. We have to make this information related. Like this ID assignment 1 and name is equal to Samir has to be treated as a single entity and not a group of separate characters. So we have to achieve this first. Second, manipulating the information inside a file is a tedious job. So somebody has to address that also. Now we will learn one file handling feature in Java, which allows us to treat this information as a single entity. But here I'm not going to talk about how to make easy for manipulating the data. So data manipulation answer, we have to look for that answer into the databases to make simple how to manipulate data. Right now, we will try to resolve this problem of representing this all information as in a single entity, which is these all characters are treated as in a separate entity for the text file. Now we will learn a skill using which we can represent this information as in a single entity. Okay, so I'll open my chat window. If anyone have a doubt in the discussion, whatever we had till the point, can raise a question in the chat box, or you can unmute yourself and ask me the question. Anyone have a doubt, or you whatever I have discussed is crystal clear? Okay, is it clear, Greg? Let's continue with the point. So now I'm going to take help of a paint to represent the information. Let me close the chat box. Let's say we have something called as class person, and let's see, this is the class, right? And in this class, I have a variable called as ID, and the second variable is called as okay. Let me use a separate box. Let me call this as a name. Now ID, let's take this ID variable, and it is going to have a data type, right? It's not a simple variable, it's a data type. This variable is going to have a data type of its own. Let me take this variable to the left. Let me use a text build and call it int, and let me go to the next line and call this as string, right? Now, when I create an object against this class, let's create an object against this class. Let's create an object against this class. And this object is going to have a information. What this information is be like, this is an object of class person, and this first object have a field called as id, which type is integer, and this id, let's say, have value 1. So this information is associated with this object. First information is there is a variable called as id, which is of type numeric integer, and it is initialized to value 1. Second information is this object also have a string variable called as name, and let's say it is initialized with value top, right? So let's assume this is the information inside the object. I can put a enter value, enter key. Yeah. So this information is inside the object. Not only that, this object is going to have a starting point. Now, see, this circle have some meaning. What is the meaning associated with this circle is this entire circle represents a block from the memory. Now, if let's say I have a memory block, RAM, in which the stack like a memory has been created, stack like a memory has been created, and let's say we have used this stack to represent this information, and in stack we have something called as id, then the value something called as a 1, then we have something called as a name in the stack, and again in the next location we have stored something called as kop. So this all information is stored on the stack. So this block here in the memory represents a one entity. So this entire block in the memory is representing single object or one entity, right? And what we want is on the disk, on the hard drive, let's say I want to store this information on the disk. So on the hard drive, let's assume this is my disk drive in which I'm actually going to store this information. Then I want this entire memory representation, how this object is actually represented in the memory. For the sake of simplicity, I want this round circle shape, oval shape containing all the information as in a single value or as a single entity, as a single object to be written on the disk as it is. So for the sake of simplicity, what I want is I want this circular oval shape to be written on the disk as it is. In real world, whatever memory representation has been used by this object in the main memory, in the random access memory, we want this all information here, this all information to be written on the disk as it is, right? As a single entity. And what second counterpart is reverse counterpart required is when I want to read, let's say this information has to be read back into the program. So I want this disk information which is written in the hard drive, this file information which is written on the hard drive has to be read as it is from the disk back into the object, right? So when I read this information, this entire state of the object has to be written on the disk as it is. And when I read back this information, the entire object as it is has to be read back. And this integer ID1, string name, KOP, everything has to come as it is. So what we want is when we read back the object from the disk, this ID1, name, KOP has to be created in the memory as in a single object. That is what we have to achieve. Any doubt till this moment? Any doubt till this moment? Till this point? Shall we proceed? Yeah. Okay, fine. So I've got one reply. Okay. So when this has to be done, when this information has to be written on the disk and read from the disk, I hope you got this concept. Let me expand this panel and take help of a new diagram to explain you the concept. This memory diagram is with us now. Okay, I haven't saved it. I don't want to save also. Now, let's say this is the disk drive and this is one magnetic tape on the disk. And on this disk's magnetic tape, this is the track on which actually the information is getting written, right? So assume this is the disk and this is the track, and here are sectors on this disk in which actually we are writing the data. So we are using this hard drive HDD file to actually write the data. Now, in the computer's world, let's say okay, it's very small. Let me increase the font size to 48. So let's say that we have this ID and is equal to 1. And we want to write this information on the disk. So what happens is this I must have a code, binary code. Assume this is the code of I. 10100010. Okay. This is the code for the D. Assume this is the code for the D. This is not a perfect code. We are just assuming this is the code for D. Then there is a code for assignment, right? So assume this is the code for the assignment, and there is also a binary code for 1. So this is the code for 1000000. Okay, now we want this zeros and all this we want it to be written on the disk. We want it to be written on the disk, and what we have to do is, let me select the operation, copy. So let's say it is here. Then there is D. And so on and so on. So this information is written on the disk, right? When you start reading a disk program, when you start reading this information from the disk, you will pick up the first, second, third, fourth, fifth byte one by one. No, that is wrong. You have to read this group and this D group as in a one entity, which will represent ID, right? Then you have to understand this assignment represents that what is the value of this ID variable, right? Which is 1. Then this assignment's code has to be interpreted. Then the actual value of this ID variable has to be read from the disk. So we want to write this circular shape on the disk. But when we when we want to write this information on the disk, it is not possible to write this all information as a separate entity. So we want this information to be written as a single entity. In the layman's term, you have a bucket with you, right? A large bucket. Also, you have, let's say, some diagonal shape. Let me see what are the shape options that I have. Okay. Uh, let's assume this is the teacup, and this is the large mug. You have tea inside this cup, right? You have this tea inside this cup, and what you want is you want this tea to be stored. So what you can do is you can empty this cup in the jar. So you will pour this cup liquid into the jar, into the bucket that you have. As soon as you pour this liquid into the jar, then this liquid will take take the place at the bottom of the jar, right? So this liquid takes the place at the bottom of this jar, and so on. Now, see, the simple way in which I can explain is, right now when this tea in this cup, it has some shape, it has some boundary, like the vertical boundaries, the horizontal boundaries, the height, the depth, the width, the length, everything is there. These all properties are lost. And when you pour this liquid into the big bucket or big jar, the liquid is going to acquire the shape of a bucket, of a jar. Now somebody say that, okay, what is the problem? You can still again empty this liquid from the bucket to the cup and you can regain the shape, whatever your shape is desired. Let's say you have one more cup of tea with you or one more cup of liquid with you, and this liquid again, there is this cup again have some liquid inside it, right? And again you want to empty this cup, second cup, into the bucket. So you did that. You emptied the second cup into the bucket. So again this cup acquired the space at the bottom of the jar. Okay, so this moment we don't have any problem. Now, let's say the second person is a crooked person. This guy is a what we can say, a nasty person, and he demanded that I want exact tea that was in my cup. I don't want a drop of the tree which was in the cup one. I want exact tea to be removed from the jar which was in my cup, and I want to use it. I want to drink it. Or let's say a better difference mechanism is the cup one contains a red color liquid and cup two contains a blue color liquid. You want to pour this both liquids into the jar. The red color liquid must acquire the bottom of the jar and the blue color liquid must not get mixed with the red color liquid. It must get topped at the above the red color liquid, and they must not mix with each other, right? So we have to achieve this. Can anyone tell me how you can achieve this in the chat box with this phenomenon? Like we have two cups with different colors of liquid or maybe cup of tea, and we want to empty cup number one and cup number two in the jar. And but when we retrieve this information or when we retrieve this liquid from the jar, the liquid which was in the cup number one must go inside cup number one. The liquid which is in the cup number two must go inside cup number two. Can anyone tell me how to solve this with this normal phenomenon, whatever scenario we have? Any guesses how you can solve this? Indexing, okay. Anyone else? Okay, so there are no answers in the chat box. So what one has to do is, let me take this new, okay, sorry. Let me take this new box here. What somebody has to do is, the, don't empty the cup in the jar. Put this cups directly inside the jar. So the liquid in the cup number one will stay inside cup number one. The liquid in the cup number two will stay inside cup number two, and so on. So let's say this first cup belongs to the person one. If he demands his own cup and his own tea or his own liquid, then there is no problem. Just you have to remove this above cups from the desk on the from the jar, reach the particular cup that has been demanded, take out that cup from the disk, again put the remaining two cups in the disk or in the jar as it is. So this will solve the problem. Now there is no confusion that which cup had which liquid. The liquid is boundary tight. The liquid is not going to lose its boundary, right? Now again, why this has to be done is, let's take a this example. Here the name of the id variable 1 and the name of the id variable 2 are the same fields. Like this is also a name, MH is also a name, and Samir is also a name. But the difference is here, Samir name title have 5 characters, and MH name have only 2 characters. So the memory required by this second ID variable to represent the name value is only 2 bytes, whereas the ID one to represent this name variable have a memory requirement of 6 bytes. If I correlate this phenomenon, if this theory with the cup theory, it means that cup number one have more tea inside it and cup number two have less tea inside it, or cup number one have more liquid inside it and cup number two have a less amount of liquid inside it, right? But the size of the cup is identical. The cup number one and cup number two are of same size, but the liquid inside the both cup is of different. Matlab, liquid, cup number one have some more liquid inside it, neck to neck, and cup number two, even if it have a space inside it, the liquid amount of liquid inside the cup number two is less. And that's why once you pour this liquid inside a jar, it is hard to identify which liquid belongs to whom and take out the exact liquid. The same phenomenon is applicable to your stream of data, right? So here, I hope you understand why this information is called as stream. Stream means somebody in. I am sure that you can recall in somebody in the start of the sessions when we correlate the stream word with the technology, computer technology, and I asked, what do you mean by stream in the real world? I am sure that you can recall somebody from your class said that stream means flow, right? Flow of maybe of water of something. In our case, the flow of zeros and ones, right? Are we clear why we need to write a state of an object as it is in the disk? Or anyone have a doubt? If you have a doubt, you can post your question in the chat box. Aditya, indexing may be the bit technical answer, and we need this indexing when we want to manage these cups inside the jar. But while earlier we used to empty these cups into the jar, that is not a solution. We have to put this cup as it is itself in the jar. That is the solution. Anyone have a doubt or any concept is not clear? I can repeat that concept, or we can go and code how to put a cup inside a file. Is it clear what I really mean? What is the meaning of stream? How it may lose the information? Okay. So again, I'll pick some general life example to explain the concept, and then we'll actually start writing the code. So there is a concept called as a serialization. So let's assume this is the class. This is the classroom, and in this classroom we have benches, and each of this bench have 2 people sitting on, right? Place for sitting of 2 persons, right? And again we have a second row in the class, right? I have second row in the class and also the third row. So these are the 3 rows in the class. Now what I want this entire class to be taken out for some industrial visit, and I want this good discipline to be maintained by this class. So what I asked is, the person sitting on the first bench of the right side row must head a queue, and this person, rest of the student, must follow the order. That is, first this row people will come out of a class in a sequential order, then the second row person will come out of a class in the sequential order. After that, the third row people should come out of a class in a sequential order. It may happen that in between there are a few benches where there is only one occupancy, or it may even happen that one of the benches is completely empty. But that is not the case. What I want is, I want the row order, entire column order has to be maintained. So there are 3 columns in my class. I want first column on the right side should leave the class in a serial order. So these people, the person who is sitting on this first bench, the first person will come out, the second person will follow the first person, then the second bench, first person will follow the second person, and so on. And a row is formed. So you have a row of people coming out of the class. So let's say this first row has been formed containing the people from the first column in the class, right? So let's say this is my first row of containing the students in the first column of the class. Now what has happened is earlier on each bench you had 2 people sitting. Right now my row, in each place there will be only 1 student. So we have changed the order. We have changed the order in which the students are sitting. Students were sitting, and we have formed a queue. So I will call this process as serializing the story, or what I'll call is when these students form this row or queue, not a row. When the students in this column form this queue to go to the industrial visit, I will call this creation of a queue process as a serialization. Students leaving this classroom's column and forming this row or this queue. I will call the process of forming this queue as a serialization process. Then let's say that industrial visit is completed, and again the students have to come back to the class and acquire the exact place in which they were sitting. So this sorry, this is a two-way process. Like first, people leave their benches and creates a queue to go to the industrial visit. As soon as the industrial visit is complete, again people break their queue and go to their exact place, exact bench, and acquire the considered place on the bench. So the process of forming a queue, I will call it as serialize, and the process of forming the column in the class in or going to a particular bench and sitting on a bench or sitting on a particular place is called as deserialization. So let's say that this first class is the classroom, and this second box is the industry. So students are going from the classroom to the industry. Students are going from the classroom to the industry. So this transmission is not direct. First, students will come out, they will form a queue. From the queue, they will go to the industry. And in industry, let's say industry has again arranged benches in the column order for the students to understand or to deliver a session. So students will go into the industry in the place where the industry is going to give a demonstration, and again will start sitting on benches, right? So student will go to the industry and they will sit on benches. So what has happened is while leaving the classroom, student got deserialized, serialized, student got serialized, they formed a queue. This queue traveled to the industry, and in the industry, the queue got deserialized and acquired its own order of sitting. Now, let's say that this classroom represents a main memory, random access memory, and this industry represents the disk. So when we send this object, the queue, from the random access memory to the disk, the serialization will happen. And when we read this object from the disk back to the classroom, from the industry back to the classroom, from the disk back to the main memory, the deserialization process will happen, right? So we have to serialize the object while writing on the disk, and we have to deserialize the object while reading from the disk. So is it clear what do you mean by serialize and what do you mean by deserialize? Anyone in doubt? What do you mean by serialize and what do you mean by deserialize, or concept is clear? Okay, so there are no questions, so I will go with coding. Let me not save this. Also, I'll not save this file. Okay, there is a program. Okay, so first of all, I need to import this IO package, right? And let's say that I have a class person whose objects I want to write on the disk, and this person object have field called as integer ID and second field, sorry, and this second field called as string name. There are two fields in this class. Now I want this object to be returned to the disk, and I just explained the process of when we write this object on the disk, we have to follow something called as serializable. On the disk, we have to follow the concept something called as deserializable. So to support this serialization and deserialization, we have to make sure that the object is compatible with serialization and deserialization mechanism. And for that, we have to follow an interface serializable. So what happens is when you implement when your class implements a serializable interface in Java, that time your class tells Java that my class maybe get written on the disk unless and until the objects of this class maybe get written on the disk or maybe get transferred on the network. So if your class is not serialized, if your class is not supporting serializable interface, in that case, you will not be able to send the object over the network. You will not be able to send the object of this class to the disk. In short, you are not able to send the object from one device to the other device if this class is not supporting the serializable interface. So in Java, whenever you have any class which is not supporting a serializable concept, then you can't write the object of that class on the disk, or you can't send that object on the network, or you can't send that object from any device, one device to the other device, in simple terms, right? So let me create a class first, sorry, third, in which I will write my main method. So public void main. I know that I'm going to do the file handling, so let me say throws exception. I do not recommend this. Please follow the try and catch when you perform assignments. You must not do this, right? Then we want to write the object, right? So I'll use file output stream class fout new file output stream. Let me call this file as it's going to be a binary file. So let me call it as a dot bat or dat, right? Let me call it a data file or dat file, a dot dat extension. Now object output stream go out is equal to new object output stream is the class which will serialize the object while writing the object on the disk as in a single entity. And I will pass the object of fout as an argument to the object output stream. Then let's initialize the object of class person. Person p is equal to new person Then p dot id is equal to 1 and p dot name is equal to string, right? Then a very simple way to write this, o dot write object is the method, and the object that I want to write is p. Okay, so the object is getting written on the in the main memory. The object still is not in the disk. We have seen this in the earlier classes. So either I have to use flush to make sure that object gets written on the disk, or in between, or maybe at the end of the program, you have to say out dot. Sorry, I should say out may give an error. O out, that'll be the word here. O out dot write. O out dot flush to make sure that the object is actually written on the disk. O out dot close when we are closing the interface, right? So a very simple, only two-line program. Let's try to compile this and see whether it is working or not. So Java C third dot Java. I guess serializable spelling I is missing. Let me confirm. Okay, I've used this E. This has to be I serializable. Okay, and now third. Okay, so Java third. Okay, main cannot find third. Please define the main method as public. Okay, I've input this string and args arguments in the main method. Let me compile. Yeah, and now Java. Okay, we will add one more line after this to make confirm that the object is written on the disk. Println. Let's say the object. What do you can say? Written on the disk. So let me compile this and let's say Java third. So object is written on the disk. Now let's try to open the file. You can see that file name is a.dat. So we are using a.dat file. Let me open that a.dat file. Here you can see that something person and some random information, some symbols that Notepad is not able to interpret. Then it is saying that there is ID, and then there is a name. Then you are using Java lang string expression. Then you have a string value and so on and so on. So lot of information which we are not able to understand is written on the in this file. If I travel to the file, okay, it's not allowing me to even travel further. So this information is written on the disk, and what value we have written? Name as a string. Let me say this is Kolhapur, and again let me close the file. Let me close the file, and let's say Java C third and run. And let's again open the file notepad a.dat. Now here you can see that the string information has been written on the disk, and is all information which notepad is not able to interpret is because this is a binary information or serialized information associated with the object. Now let's use this same program to read back the object from the file. So while reading the object, I don't need this classes used for writing the object on the disk. So I'll put a comment tag to everything, and I'll keep the program for reference, right? Now for reading, as you have seen in the earlier classes, when there is something called as output stream or output writer, there is always an input stream or input reader in the Java. So I will use object input stream, let's say OIN is equal to new object input stream for reading the object from the disk. And here I will pass new file input stream as an argument. And here the file that I want is a.dat. So I'm using a shortcut just to show you that this is possible Like instead of writing two separate lines, you can combine this and pass the runtime file name to the object output stream, object output or object input stream, or any buffer that of your choice. When there is a write object method, there is also a read object method. So OIN dot read object. Now write object method has an argument which writes the object, desired expected object, serialize it, and then write it on the disk. The read object reads the object from the file and returns it. Now I am sure that you are able to recall that everything in Java is inherited from base class, which is an object, right? So when, let's assume this disk file, this a.dat file that we have created, dir. So this a.dat file is a industry now, or it's a classroom now, and the main memory is the industry, and we want to transfer the students from industry to the main memory, or we want to read this object from a.dat file to the main memory. So on the disk, this is a Java object, and in the main memory also this is a Java object. But in the main memory, this is not only the Java object, this is also a subclass called as person, which is inheriting from object also. So it is object of person when it comes to the main memory. But on the disk, it simply represents one of the object mechanism scheme of Java. So this read object method to support any object. Right now we are writing object of class person. What if I want to write also object of class teacher? What if I also want to write a class of object of class student? So this read object mechanism do not get applied to the user defined class. It uses the mechanism of Java to read and write objects to and from disk or to and from devices. So this read object have a return type, which is a base class object of Java, that is object. And we are not expecting a base class of Java, we are expecting an object of person. So what we have to do is we have to typecast it. This story we have discussed many times and mostly in the inheritance, right? So what we have to do is here I'll write person P, but the returning object is of not type person, returning object is of type base class object. So I have to typecast it. I want to convert this object into person. And this typecasting will be successful because we are reading an object which is of type person. And this typecast will fail if in the file you have object of teacher and you try to convert it to the class person. Fine. So right now this typecast is going to get successful and object will be returned to the disk. Now let's display the object on or object or its values on the screen. Out.println. What I can do is I can say p.id and system.out.println p.name, p.id and p.name. So let me compile quickly. Java.third. Okay, if there is a spelling mistake. Sorry. Java.third, and now this program must display the information. Now this object is read fact from the disk. So this is how you can use the object selection mechanism to read and write objects to and from file. I hope you got the concept. In the next session, we will again discuss some of the other mechanisms of file handling. The assignment number 1 regarding the file handling is already available on the Moodle, and soon the object selection related assignment will come on the Moodle. It's already 10:03. You people can leave the meeting and join the next lecture.